Can you hear it? Let me see if you... Sorry. Seems like my mic is off. Okay. Sorry, thank you for the comments. I didn't realize it. Okay, so I'm gonna start over. So this is a tutorial live for Houdini, and this is 136th episode, which today I'm going to create a circular route procedurally from a OpenStreetMap by specifying the starting point and a length of the route. And you can then randomly generate a infinite number of route based on those criteria. So right now I have a parameter for the distance of the route. It says 4057, and based on, and the starting point is here where the yellow triangles is pointed at, and you can then create an infinite number of complex or uncomplex simple route based on this informations. And you can also change those parameters to change the complexity of the route. Several things you could do, and this is what I'm going to try to teach you today. Okay. The idea itself is pretty simple, but I think it's pretty usable for many cases. I used it for one of the artwork we did in a group to generate a walking route for people for a mobile app, which you can use that to navigate your walking experience. So could be used for real life experience as well, probably, but maybe in the gaming world as well. The route is pretty randomized, so sometimes it's not really efficient for walking or biking or anything, but still it might be interesting. So hopefully you find this interesting as well. Okay. And the plan is to start with the map, importing the map, filter it with filter out unnecessary informations, and set the starting point, set the length of the route, and then the main things is to create a route using a noise function in this case to make it random. And there are and I'm going to implement several parameters where you can change the randomness of the route. Okay, and I think this part is going to be the main part for today. Then finally you can visualize it. Okay, so that's my plan, and I have started off with downloading one of the map from the OpenStreetMap service. This is a free map service which is open source. You can download the map for free for any areas if it's available. I have just downloaded the map close to Tokyo Station, but you can just choose any place you want. Okay, and I have imported the OSM map by using this node, labs OSM import, where you can import OSM files that you download from the service, the web service. Then you can see things like this, which has a bunch of rows and buildings. Now, I don't really need a building for this tutorial since this is about the route, but I guess having building as a three-dimensional boxes might be pretty, so let's have that first. gonna type OSM again and use labs OSM buildings first to just create simple building blocks. With some of the building doesn't have a height information, so for those I am going to check this generate buildings on missing data, which will create random height buildings based on the standard level height. Okay, which looks already good, so I'm just going to use this one as a final visualization of the map. Now let's go to the main part, the roads. So again, you search for OSM. This time I'm going to use a labs OSM filter. Okay, and from here I am going to pick a necessary informations. In this case I want to use the road, so I'm just checking the road and turn off buildings. Now in terms of the road, there are many types. You can also check other and see the whole rows. I think the other one also includes the walking road street, so I'm going to include it. But instead I might want to disable some of the big road or motorway road, such as the highway. In this case, the motorway will be the the highway road, I think. So if I uncheck it, does it disappear anything? Does it removes anything? Not much, I guess. So I guess there is no motorway. If I uncheck primary, now the main road seems to turned off. Maybe I want to include it. Okay, so except for the motorway, maybe I can just accept all the road types for now. Maybe I can also include motorway anyway. But let's try to do with these. Okay. Now, the main goal of this setup is to create a circular road, meaning the starting point and end point will be the same position. You go from one point and specify the distance, and in the end of the route you have to go back to the same positions. So that's the circular route. And in order to do that, the road has to be connected with other road. So you cannot go to some one-way road like these, one-way street like these. So for this kind of one-way street, I just want to trim it out so that I don't have to use it as a candidate for the route. Okay, so that's the next thing I would like to do. Okay, so let's try thinking about that. But before trimming all those one-way street, first thing I want to do is to check the attribute, what kind of data I have. It seems like I have bunch of primitive attributes for the rows, and I think most of the attributes are unnecessary for my purpose, and most of them are pretty empty, so I think it's pretty useless. Most of them are pretty useless, except for something like latitude and longitude and stuff like that, or a building road type and so on. So next thing I would like to do is to purge all the unnecessary attributes. Okay, especially if there are empty as a data, then I think I don't really need those data. So let's do that. And well, in order to check whether a primitive data is empty or not, first I will try to promote all the primitive attributes, which should be all strings, I think. even if it has a number value. I think it's being imported as a text or string by using OSM import. So consider this is a string. I could use an attribute promote from primitive to detail and then use sum to everything, every attributes, and then don't delete the original, which will create a summed up attributes. All the primitive attributes will be transferred or copied to a detail attribute as well. Then all the data has also been summed up. So if there's any data available for each of the attributes, that means those attributes are being used, so we can maybe keep it. But for those attributes which are empty, then those attributes are unused, so maybe I can just delete it or purge it. And I see that I have so many empty attributes on detail, so for those attributes I can just delete it both on detail and primitive. Okay, so that's what I would like to do, and I am going to use primitive wrangle for that. This step is not really important at all, but I do like to make it clean before getting into anything, because I would like to see an attribute without having any garbage data. Okay, so first thing first, I'm going to get all the list on the detail attributes, so in order to do that, I can get the list of attributes on the detail attribute names by using detail intrinsic function, and the intrinsic attribute name is detail attributes, which will give you all the names of the attributes available in detail. Now for each attributes in detail, I'm going to loop through it, and for each if the attribute's been promoted from primitive, then primitive should also have the same attribute. So you can check the current attribute, and I can also check the attribute type from the detail, and I think most of it are a string attribute, but let's make sure. So if int type is equal to prim attriv type 0, this will give you an information if this attribute is available in primitive and what type it is. And if it's equal to 2, that means it's string. Otherwise it's float or integer or some other informations, or null. So only if it is string, I'm going to trim out if the detail attribute is empty. So check the detail attribute value with this name, and if this value is empty, then I can now delete the primitive attribute, the same name primitive attribute, as well as a detail attribute. Maybe I can remove the detail attribute outside the conditions, because this is unnecessary anymore. Now what happens? Oops. Okay. Mistake. Has to be attribute names Oops. Okay. Now, let's see what happened. Now I think lots of attributes has been trimmed out or purged compared to previously. Yeah, I think you have now half of the attributes out of all. Okay, so that's just the cleanup phase. Now next, I'm going to clean up this geometry itself. Okay, first I'm going to use the fuse so that all the lines is going to be connected, sharing the same points. Then try to trim out these lines which has only one direction or some dead end. Now the condition for those lines is pretty simple. We want to remove the points on the tip, and the tip point only have one neighbor, meaning if the point is right here, then you have 3 neighbors. But if the point is here, then you only have 1 neighbor. So whenever the point has 1 neighbor, then that means you're at the tip of the route, tip of the road, which is the dead end. So those are the points of what I want to remove. So I can set some conditions with the point wrangle. If neighbor count at point is equal to 1, then I can just remove it. Okay, so it's been trimmed out, but I still have these. Reason is because I have just trimmed 1 point, but I still have several points. Seems like still have several points here. So this could happen, so maybe it's better if I do this recursively until you don't have any deadline anymore. So to do that, I can just use a for each loop with the feedback setup. Fetch feedback and feedback each iterations. And then set the count number to something like 100, then you'll be able to trim out all the dead ends at some point. Now, you could also say it's 1000, but at some point, it's pretty obvious that no dead end is gonna be available anymore. So when that happens, then maybe I want to stop this loop to efficiently close the loop, because running this unnecessary functions for 1000 times makes no sense. So let's do that. I'm gonna make a null node here on the first input from the for each begin. Let's call this loop end 1. And what I'm going to do is to check if the total number of points has changed from previous loop iteration. So I'm going to create another attribute wrangle. Saying, or maybe what I could do is to give another null node here, and let's call this, I'm going to say L start 1 for this one and L end 1 for this one. What I want to check is if the point number at this point at this node and point number at this node is same or not. If it's different, then some of the point has been trimmed out, so maybe we still need another loop. But if it is the same, then that means there are no dead end lines to trim anymore. So that's when you want to stop the loop. So let's make a condition for that. For the stop conditions, I'll say endpoints at end equal to endpoints at start. If it's equal, then that's when you want to stop. And if it's equal, this will give you 1, which is used as a stop condition. And now if I have this, then it's stopped at 84. So 84 is the number of iterations it needs to be run in order to trim everything. So that's good. We don't really need an efficient unused loop anymore, which makes the things a little bit faster. Okay, so cleaning up the line. Next, what I would like to do is to since I'm going to create a circular route, I want every lines to be connected somehow. If not, then maybe I want to trim that part. For example, what I mean is that if I double click one of the lines, if it's connected, then it should all highlight the one that's been connected. And if I type delete key, then I would like everything to be deleted, but I see some part are left out, which is some small island which is not connected to any of the road. This kind of small island. So for those, it's not going to be used for the circular route, so I would like to delete it as well. So let's do that. To define where I should delete, I could use a connectivity node. Connectivity node, which will give you an information which primitive or points related to which island. For this example, I'm gonna use the point-based connectivity. And if I check the point attribute for the class, it seems like I have 9 different islands somehow. And 7 through 0 to 7, I see a small number of points, and number 8 has tons of points, which means the number 8 as a class is the biggest island or biggest connectivity points. So those are the points I want to keep, and these points I don't really need it because it's not going to be used for the circular route. So to delete those, I think I need to count up what's the maximum class. Okay, so which class has the maximum number of points? So let's do that. I guess there are many ways, but I am going to use probably a detail wrangle first, or maybe point wrangle. Then give an attribute called class num. So try to count up a number of same classes sharing with your own attribute. I'm going to use a function called find attribute count for the point attribute for the class, using the same class to search. Now this will give you a total number of same class number. So for class 8 you have in total 8,600 and so on. For 0 just 1, for 6 you only have 4 and so on. So I want to only keep those value which has the maximum number of class num. So to check what is the maximum number of the class num. Maybe I can use attribute promote. For point to detail class num, get the maximum, don't delete it. Maybe max class num, which will promote the maximum number of classes to detail attribute. Then I can use this information to remove the points which doesn't have this number as a class num attribute. So I can say, first of all, get this information, int max class num. If a class num is not equal to max class num, then you're in the small island, you can remove that point. See. Now the little rectangle has been deleted, and I think you have no more other classes. Everything is now connected as one piece. Okay. So that's another cleaning step. These steps are pretty small but pretty important, I think, in order to make the final things organized. Okay, finally, I am going to connect clean to remove a unnecessary empty primitive. I think this will give you purge some unnecessary primitives. Okay. All right. Now let's also use fuse just in case. Maybe I don't really need it. Let's check. Okay, same. So maybe I don't really need this one. Okay. Next. Next thing I would like to do is to clean up the road geometry itself. For example, it will be better if I don't have these points in the middle of the road. Meaning, if it's straight, then maybe I can just dissolve these points. Because these points are going to be used for later for route candidates points, and I don't really need the in-between points especially if it's on the straight load. You can just dissolve it and nothing will change the result. So just to make it more efficient, I'm going to try to dissolve these points which is on the straight line. Now the easiest way to do that is to use facet and use remove inline points, but sometimes it doesn't really work. For example, you don't really see these trimmed out. I guess that is because these are all separated points. So first thing you need to do is to make it as a polyline using polypath. Now a lot of the lines will be connected as a polyline, one single polyline. And now you'll be able to use facet with it. And for example, if I want to trim out these, dissolve these points, I think I need to raise up the distance value here a little bit. Now, the downside of this attribute or the parameter is that it is not based on an angle, but it's based on the distance. So sometimes it just trims things that I really don't want to. For example, it also trims out these arcs as well, which I don't really want to. I only want to trim out the straight areas, such as these, but this point is not being dissolve, but instead these arcs are being dissolved. So it's not really related to the angle, but it's distance, maybe from the start point to the end point. So instead of using this to dissolve the points, I'm going to just use an angle-based function, which I need to build it by myself. Okay, a simple but effective way. The idea is to get, for each point, get the neighbors on the both side, and only if the point has two neighbors, which means there's a chance that it's on the line. Okay, and if it has two neighbors, and if the first neighbor and the second neighbor direction is more of parallel, then that means you're in the straight line. You're on the straight line. That means you can delete that point to dissolve it. So let's check the neighbor point numbers. If it's equal to 2, then get the neighbor points. Then get the point information for both neighbors. Get the point position of the neighbor points. That. Then need to get the direction from the current point positions. So the first direction, let's say npos minus at p. So from at p, the current point position, to npos 1. Let's normalize it. The second direction, since I want to check the if it's parallel or not, I'm going to say from npos 2 to at p. Okay, so having these two directions, I can now calculate the angle between those two vectors by using a simple function. First of all, calculate the dot product between two vectors and use a cosine, arc cosine, to calculate the actual angle. This is the function you can use to calculate the angle between two vectors, which is available in between 0 to 180 degrees. Okay, now that I have an angle, I can now check with an angle parameter if I should delete it or not. So if angle is less than some parameter value, and since this is the radians, maybe I can use degrees as an input and convert it into radians and remove point. Okay, let's see. And let's set the angle maximum to something like 30. So let's check this. Oops. Where'd it go? So let's check these points. If I increase the angle, you can see that the point has just been deleted pretty quickly. What about these one? This is like 1 or 2 degrees, I guess. Nope. Maybe this is not connected. It is connected. This is not being deleted. Maybe something is out. Maybe it says more than 10 degrees, so maybe that's correct. So this is not straight enough. But overall, I think this seems to work. Yeah, these part as well. I think it is removing points if it's close to straight line. Yeah. So let's say I'll set the angle to something 1. Yeah, I still have those in between points, but I guess this will reduce a lot of points, even with just 1 degree parameter threshold. So before I had 8,638, now I have 7,500. Okay, so maybe it's good enough. Okay, finally, after trimming out all the points, unnecessary points, I'm going to convert back to the line by using convert line node. Okay. Right. So I think I am pretty much done with the cleaning part. Next, what I'm gonna do is to use this information as the base to create the actual route, and that part I'm gonna use a noise function for that. Okay, so let me explain what I mean by noise function. Okay, so first of all, I have a bunch of existing road. Okay. Now, what I'm going to do is to try to create some noise map on top of this road. And use the area created by this noise map as the candidate for the route. So meaning what I would like to do is to create a route based on this map, using the existing road, of course. Okay, so that's the general idea, the basic idea, and I'll show you how exactly I could use this idea to create a route. Okay, so first thing first, I need to map the noise map onto the base map itself. And to do that, what I'm going to do is to convert this map into a flat surface, trimmed flat surface, which has these edges as a surface. Okay, meaning I have this grid, and this grid is going to be, where is it? This grid is going to be, oops, didn't want it. This grid is going to be divided. I mean, each line of the grid, like these one, is being stands for the road edges, road lines. So instead of having these perpendicular lines, I want to use the road lines to split the grid. So that's the idea. Okay. So in order to do that, the easiest way I could think of is to first of all create a bounding box as a flat surface, using bound from this curve network, make it as a rectangle, which should create one primitive. Then use the Boolean node to Boolean with these curves. Now I don't think you can directly Boolean with the curve between surfaces, so I'm going to first convert this line into a extruded surface by using polysurface. Poly extrude. With a little bit of amount of extrusion height, and for the direction of the extrusions, maybe I have to specify the point normal by myself. So I'm going to create a attribute for n, which goes up 0, 1, 0 as a vector value. Now I can use that attribute to extrude upwards like this. Okay, since I moved for 10, let's make this transform or translate it -5 to to the y direction, so that the middle part of these rectangles collide with this plane created by this bounds, which will enable us to do a Boolean operation between these two surfaces. So create a Boolean, and you set the Boolean setup to, first of all, surface by surface, and I'm going to choose a shatter, which will shatter the surface into splitted surfaces. There you go. Okay, now since this is being made out of a boundary surface, I have these unnecessary surfaces on the border, so maybe I can just delete those. So let's do that. In order to do that, I have to define where these primitives are. It is on the border, obviously, so maybe I can give a conditions to delete the geometry on the border. So first of all, I'm going to fuse the geometry, then try to use group. See if I can pick up the ones on the border. Include by edges, unshared edges. Okay. Seems like I am picking the ones that's on the border, and these are obviously unnecessary surfaces, so maybe I can delete that. Gonna name the group border and delete those border geometry. There you go. Now let's recalculate the normal just in case. Okay, and check what we have here. So we have a bunch of squares, and next thing I would like to do is to map this noise value on top of this surface on each point. That's what I would like to do here. And let's see how I can do that. Okay. But before doing that, I think it's a good idea to have a little bit more edges and points by keeping those original edges. So let me try that, or maybe I might not need it. Let me see if I need to do that. Well, thing is, maybe I think this is the time I might want to map the noise value. Okay, and in order to have a noise value, I think it's a good idea to have a lot of triangles instead of having a sparse number of primitives like these. But let me just try with these. If it doesn't work well, then I can always do additional remeshing to this. Okay, so have this gathered. How do I call these? Okay, now let's try to use a noise function, use point wrangle. And see what kind of map we could get using this function. Okay, so first of all, use noise based on the point position maybe, and some scaling multiplier plus some seed information so that you can change the random type, or and I could say let's see, this will give you a value in between 0 to 1, right? So let's see. So promote the parameters. So you have scale, you can have seed. Now let's try to use it as a color first to see how it looks like. Use it as a color attribute. Now it's a bit hard to see the gradation here. Maybe the scale is too big. Let's set the range to 0.01 as a maximum. Okay, now I start to see some maps here. Okay. Now I might want to subtract this value so that I can have a threshold where the value is equal to 0, and to create some pond-like shape from the noise map. So to do that, I could subtract this value by some additional threshold here. Maybe it's a good start to subtract by 0.5, and then you will going to have a map between the black and red here. And let's say I want to have only the red part as an island, which is going to be the candidate for the route. In order to get that information, or in order to get that geometry, maybe you could, for example, use clip to clip just the red part. Now this doesn't give it an option for a custom attribute, so what I could do is to move the point a little bit up and down based on this n value. Okay, so shall we do that? N value. Okay. And if I have this, I can now see that only the red part has been trimmed. The black part has been deleted. And maybe I can use these as a candidate for a route. The problem is that this is a bit sparse. I mean, it's a bit hard to create a connection, a one circular connection, if the length is pretty long. So maybe I need to reduce these threshold value a little bit to have necessary amount of island. Okay, so maybe 0.45 or 4 is good enough. And if I change seed, I can also change the type of the the shape of the whole island. If I change the scale, I can change the whole scale as well. Now, another problem. If I am to set the starting point for the route, then starting point has to be inside the island, right? Has to be on the red spot. Has to be on top of this red spot or red areas somehow. So that needs to be done as well. So to do that, first of all, I need to set the starting point for this route. So I can either use latitude and longitude, or I can just geometrically put a simple point to use it as a starting point. Now, to use it procedurally as a system, I think it's a good idea to use maybe both ways. Sometimes it will be great if you can set it with the longitude and latitude so that you can automatically run this file externally, maybe from some app, and have this set up on the server. If you just throw those latitude and longitude parameters, then you can just send back the raw data. If you need to do it manually, then you can not do that way. You cannot automate stuff much. So maybe I will prefer using latitude and longitude, but it always a good idea to have a custom manual point to test as well. So let's have it both ways. So let's go back to the original map, or the base map areas, and let's check if these points have a latitude and longitude information, and there you have it. So I can always use these as a reference to search, but I don't know if these values are correct. Maybe this is not so correct. These values are a bit off. Maybe if I go back to the original, yeah, these are the right latitude and longitude. Maybe throughout the Boolean step and so on, the value has been messed up. So maybe I should go back somewhere around here, or maybe to the original to find out the points where I need. Okay, so I can go back to the map, and let's say I want to start the route somewhere around here on the corner, on the crossing of maybe some here, Muromachi. So there, I think if I double click it, I should be able to have these latitude and longitude values. I can copy this and use it as a starting point. Okay, so how do I do that? I can search for those both values using, in this case, I can convert these two values into vectors and use something like PC find to look for these custom attributes. So let's have point wrangle right after importing the awesome filter. let's have additional position attribute for as a vector using having latitude and longitude as a value. Now let me go back to this part as well. Let's see. So this is where okay. So I think the longitude stands for x direction. Was it? Gotta check. So the vertical line stands for a longitude and horizontal line stands for a latitude, right? So latitude stands for the y direction, longitude stands for the x direction. Okay, so this is x, this is y. I mean, it's not really important, but just to set my mind correctly. So let's have a latitude as an x value, I mean longitude as an x value, which is this one, and I believe these values are string. So I think I need to convert this from string to float. So A to F. A to F for the latitude. And if I check the position, nope, doesn't seem correct. Am I missing something? Latitude? Maybe it wasn't string after all, if it's float. If it's float after all. It was float after all, sorry. So this is float, so I can just pass it to a vector value. Okay, now's the time I need to set a starting point somewhere. So I'll create a null node, gather all the parameters that I want to control here. Let's have two flow values. Latitude, start latitude, and start longitude. Okay. Then copy what I have here to here and to here. Okay. Maybe I should set the range here. Okay, now I have this starting point, then I can now specify which point is going to be the starting point by searching all the points available in this map here. So let's do that by using attribute wrangle, because I just need one point, and connect it to the second point. And let's start find the position. Now for finding the position with the specific attributes, I can use PC find. And from the second input, I am going to search for the position using this vector value here. So let's get that information. And use it as a searching point. What else do I need? So PC channel, P, radius, and max points. The radius is, I don't know, could be any value, like 100 meter. Or maybe, I mean, this value is used for the amount for the degrees, so maybe 100 is pretty big. Okay, I can just say 1, I guess. Then I only need the closest point, so I can just say 1 for the maximum points. Okay, we'll give you a list of points, searched points, and if the length of PTS is equal to more than 1, then I must have found out the point that I need. And to that point, I'm going to add a new point where I'm going to use it as a starting point. Get the point attribute. Oops, I already have it. This has to be vector value. Okay. Right. Now, let's see. Do I have anything? Nope. That is because I don't have these value yet. Copy this. Latitude. And the longitude. See if I got any point. No, not yet. If I increase the degrees, still not. Maybe something's wrong. So I have latitude, longitude. Use the vector. Is this as a third search? And I'm looking at the second input, which has these points attribute position. It looks correct. And maybe something is missing here. Latitude, longitude. Long Latin. Let me check the number of points. Oh, wait a minute, I forgot to make it detail. That's why. Okay, now I have 1 point here. Detail always runs even though you don't have any first input, but if you put it to points or primitives, the code doesn't run if you don't have a first input. So that was the problem. Okay, now I should have 1 point. Let's check where that is. The whole map is like this, and the point that I have just created is where is it? Do we see it? Okay, so it's on the crossing, which looks the same point as I set up right here. Okay, it's good. So that's one way I can set up the starting point. Another way, much easier, I can just have add point and use it to search for the closest point. Okay, so I can use either one. Maybe I can place the starting point candidate here and look for the closest point on top of this map. And for that, I think it's better using the trimmed a map somewhere around here. Maybe before doing the booleans. Do we still have latitude along? Yeah, I think it's I still have a right value here. So maybe I can do the start point search right here, right at this timing, because I don't want to fit the starting point to the dead end after all. Okay, so for this one, I could use a point wrangle 2, or maybe a detail wrangle, and connect this to the first point, or maybe I can still set it to point, connect the whole map to the second input. This is more manual. It's pretty easy. You can just use something like new point function using the current point positions and get the closest point on the map. Replace your own position with this near point position. And now it should be snapped to a map. Alright, now you can choose which one you want to use using switch. Let's call this start PT. Right. Now let's have this using object merge so that I can bring this down without dirty spaghettis. Okay, so where was I? Now I have a starting point. Next thing I would like to do is to make sure the noise map can contain these points, the starting point. So to do that, you kind of need to offset the noise if it's not on the, if it doesn't have points on it. Maybe I should make that condition first. So currently, as you can see, the point right here is not on the red map. So which means I have to move these map so that the point can be at least on the border or inside the map. Maybe on the border sounds fine because what I want to have a circular map. So maybe I can use these edges as a candidate for the route. So let's try to move the noise map itself so that one of the border will be aligned with these points. Okay, so that's a little bit tricky, but you could definitely do it. So let's think how I should do that. Okay. So, in order to do that, you need to think about, for example, if this is offset map, and if this is the starting point, maybe I can search for the closest border point to the map. In this case, if I project this point to the map, maybe the closest point is somewhere around here. Okay. Meaning if I could offset this map a little bit to this direction so that the points will be on top of the border, there's no problem anymore. So that's what I would like to do here. And to do that, I think I need to do some operation here. Okay. Well, what should I do? First thing first, I do believe I need to have an initial map being created like this. Okay, so maybe this is the initial noise map. Now, based on this, I could search for the closest 0 value from this point position. Okay, to look for the offset, how much I should offset it. Okay, so how would I do that? In order to search for the border, let me see. If I look at the noise value, which is currently called as val or CD, if I check the CD, if the CDR is close to 0, that's the point where I want to pick, and also closest to the current point. I mean, it doesn't really need to be closest. If you can just find any of the border point to where the border value, or where the border is, when this color red value is equal to close to 0, then that should be fine. So to do that, maybe I can use another PC find, but PC find only looks for the existing point. So maybe in this case, it's better I use UV sample. Use this color value as an UV instead. Okay. So move noise map or offset noise map. Connect this starting point. Okay, let's see. Now, let's first search for the point position where you have a color value equal to 0, 0, 0. UV sample, and UV sample will allow you to export any attributes you want. In this case, maybe I want to have a point position. So 0, P as an output, and CD as a UV, and 0, 0, 0 for the searching value. This will give you a point position, which can be used in an offset value, I think. Okay. Now, I can now use this offset to recalculate the noise value to see if using the offset will give you a noise map where the border is aligned with this point. So the conditions that I have as a noise value is like these. So I can just copy it here using the same parameter. Has to use the same parameter. So copy parameter, copy the seed, copy the threshold value. Okay, now I can now then use this offset value here with this noise value. Okay, and to do that, now I also need to think about the starting point position as well, I think. Isn't it? So let's get the starting point position as well. Start position. Okay. Now, I can then say for this point position to subtract with starting point position, which will offset the whole point so that this point will be in the used as a origin. And now add it with the offset value that I got here, which then move the origin to this point. Now what will happen? I'll rename this to SPOS. And let's see what would happen with this. I'm gonna update the color. See what happens. It's a bit hard to see where the point is, so I'm going to use a copy 2 points. Now I'm not really sure yet if this is on the border. Wait. Okay. My mouse is a bit stuck. What's happening? Something. Okay. Okay, it does look like close to a border, but if I trim it, maybe not. If I change the, let's say if I change the starting point, let's set the starting point to manual so that I can test out. Okay, so obviously this is not on the border, so I think I'm missing one step here. Okay. So I guess So this is the offset point, right? What if I do like this? Nope. Didn't really change anything. Oh, the reason why the clip doesn't work because I had to change this with the enval. Okay, so let me make this back to the original. Okay, so maybe it still doesn't work. I move the point. Okay, so it is offsetting based on the starting point, but I am not sure if this is on the border, close to the border, but not sure if this is correct. Pretty close. But let's say if I change the parameter like scale. So this is not good, is it? Sometimes it's out of the border, sometimes. Okay, so I think I'm missing one more steps. I think I will need to calculate the flow value, the noise value, only with these offset value as a offset noise value. Float s noise is equal to, let's say s val is equal to just with these offset. Okay, and now I could update the final value with nval minus sval. Okay, which will probably give the result that I'm looking for, hopefully. And so currently it seems like it's on the border. If I move the point, okay, and if I change the parameter for the noise, yeah, it's always on the border. The noise map is always on the border. I mean, the starting point is always on the noise map. Even if I change the seed or scale or threshold. Okay, so that looks good. Okay. So now that I have a base set up for a map, next thing I should do is to use this map to actually create a route using these as a candidate or the base. Okay. Didn't understand UV sample trick. Would you explain this? Okay. UV sample, where did I use? Okay, this one. So previously I had this color value, which is made using noise value. So x for the color is being used with the noise, y and z is 0. So making from black to red color. Looking at the point attribute, you have all the CDR, CDZ, and CDB, and R stands for the red color. Okay, and you can, what I wanted to do is to find for the color, or find for the point number where the color R is close to 0, which is somewhere around here. Okay, and I think there are two ways to find for those point using Houdini's Vex. One is to use PC find, which you can use to search for the custom attributes with some custom criteria. In this case, you can use set 000 as a criteria to search for it. But that will only give you the exact point number. Instead, if you use UV sample, that will give you an interpolated point position. If you check this value, this is not exactly a 0 value, but it's a little bit, pretty close to 0. But if you really want to have a exact 0 value, then you might need to interpolate the point position, which might be in between some points and other points on the map. And UV sample can be used for that. And this is where I'm using it. UV sample 0. So what I want to get as an output is a point position, and what I want to use as a searching attribute is CD, and 000 for the searching criteria. Searching query. Okay. And as a result, you get a point position where you can use it to offset the noise map. Right, so that's the trick. Anyway, the point is supposed to be on top of some of the points on the map, so maybe I can still use PC find after all. But in some case, if you don't have that kind of conditions, maybe having UV sample might be a good idea in some cases. Okay. So let's go to the next step. Next, I want to map the current primitive before clipping. I want to map the color where I can use it as a candidate for the route to the original map from this clipped island. What I can do is just search for the closest distance from the original map to this pond-like shape surface. Maybe I can use a primitive wrangle. And search for the surfaces with the distance, maybe. Let me see if that's correct, if that's what I did. For example, if you say search for the distance from the second input, and if the distance is close enough to 0, then maybe you can set the color to red, else set the color to white. And let's delete the point color attribute. So looks like this, but it's a bit looks sparse, especially like these points, which is supposed to be filled like that because it's on the same position. But I realized in order to use clip, I have changed the height of each point in order to clip, so I need to make this back to flat surface. So let's make this flat again, making the Y attribute for the point position to 0. Now, still has a searching problem. Maybe I should give a little more threshold. Maybe I don't really want to rely on the distance, searching distance, but instead maybe I can check for the whole primitive that is being kept left. Look for the primitive informations, like based on the primitive number, and based on those information maybe I can color the original primitive. So to do that, let's give another primitive wrangle before clipping. Copy the primitive number as an attribute. Okay, and check if it has its primitive number available. If it's available, then even 1% of the primitive is kept by clipping. So in those cases, I can maybe keep it red. So find attribute val from the second input using primitive attribute. The name is primn using current primitive number. And if this is more than 0, then that means you've found something. That's when you can set the color to red. Else white. Okay, that looks much better. Okay, now I can now change these noise map to see the differences. Okay, scaling gives you these information. This is the seed. This is the threshold. Okay, I go with the threshold 0.45. And I'm gonna increase the scale a little bit more. Okay. Now, thing is, it's also keeping areas which is mostly clipped out. So maybe I can calculate the areas and see if 50% of the area is being kept, then I can use it red. I can transfer red. If not, transfer white. But anyway, let's go with this for now. I think this is good to start with. Transfer. Okay, next step. Oops. Now that I have these candidates, it's time I create a route randomly. And with specified lengths, of course. Okay, so let's do that. Now, first thing I should do is to specify the parameter for the lengths, I guess. So let's do that. Give a float number. Let's call this distance or the length of the road. So this is the OpenStreetMap is the unit is meter. So 1000 meter means 1000 meter, 1 kilo, so on. So let's say maximum is 1000. I mean 10,000. Yeah. 10,000 is pretty... Yeah, 10,000 is... Let's set 10,000 as a maximum, meaning 10 kilo meter. And I'll set the initial starting point as a 3,000 meter, which means 3 kilos. And try to use these information to find out the loop. Okay. So, what should I do next? Next thing I would like to do is to delete the white area, which is not going to be used anymore as a route candidate. So let's delete it. To delete it, maybe I need a group information, so let's give those a group. If it's red, I'll say candidate. If it's white, I'll say maybe I don't need it. Okay, so delete the non-candidate group. Right. Okay. Now next, let's check the starting point again to see if it's really on the red geometry. Okay, so there it is. So now the idea is, from this point I am going to expand the selection on the geometry, maybe starting off by somewhere around here, then calculate the total length. If it's close to the parameter that I set here, 3000, then finish selecting the primitive and use those outline a boundary curve as a route. If not, then continue expanding the selections, maybe randomly, until the border length is equal to the parameter that I set. And that's the main algorithm that I use here. Okay, it's pretty simple. Recursively expand the selections. That's totally it. That's it. Okay, simple enough. Let's try to do that. Okay, so obviously I would need a feedback loop. So let's create that one. Let's create a loop for each number. Set it as feedback each iterations and fetch feedback, my favorite. Right, and let's also set a starting primitive. Choose one of the primitive which is connected with this point, either this one or this one or this one, to be a starting primitive geometry for expanding. Alright, so let's do that. So to make it easy to see, let's start off with white color for each primitive and restart from here. So let's have primitive wrangle and starting point connected to the second input. Actually, I only need to look for one primitive, so instead of using primitive I can say detail. Okay, now look for the starting point from the second input. Okay, and look for the point corresponding point number from the first input. at this point, let's set the point group to this point called start. Which it could be useful later. Now, let's find out the connected primitive from this point. I gotta make sure this primitive is all being connected. Yep. If I double click it, it's all connected. And you can now see that there are several separated islands, which is no longer available for a route candidate. So later maybe I want to delete those isolated islands and only keep this one as a candidate. Okay. So, and I want to make sure if I can avoid having these separated here, if that was available. Nope, this actually has a hole here, so which is not possible. So I think this is correct, having these separated as an island. Okay, so going back to where I am going to set the starting primitive. For this point, I'm going to search for a connected primitive using point prims. Now, what I want to do is to randomly pick one of the primitive out of these list or array. So let's create a random function using some seed value and multiply by the lengths of primitives. And maybe I want to have additional value for the seed. Okay, so for example, plus endpoints 0 plus some random value. Okay. Now I have this seed value here. And I have these index, and let's also make it with floor. Now I can get a random primitive number by using this index and try to set some color to this. See if I'm getting the correct attribute. Okay, so the initial primitive that I got is this small area here, which is fine. Okay, let's also set some group here. Set prim group. I'm gonna name it fill. And I also am going to set additional group here called run, which is going to be used as the newest updated primitive. Fill is being used for the filled up geometry, which is going to be used as a route candidate. Okay. Starting primitive. Right. So I am ready to go for the actual main algorithm here, implementation here, using recursive loop to expand the selection until the border length gets to 3000 in this case. Okay, the fun part finally comes. Okay, so expanding part. I think I should expand it randomly. So I'll use primitive wrangle as a first node inside a loop, connect the metadata to the second input, and call this expanding. Okay, so I need another random value here. I'm gonna get the detail. I'm going to use this iteration value as one of the seed value. I'm going to get another parameter called seed. Okay, now in order to expand from the primitive, you need to specify from which geometry you're going to expand. So I'm going to use this run group as the starting point for the expansion. Okay, now set some random seed value, and first thing first, I'm going to get all the neighboring primitive using polyneighbors. Now next thing, I would like to get a random number of primitives found inside its neighbor primitives to be used as the filled geometry as well as the next run primitive, next run group. Okay, that's what I would like to do. So let's do that. To do that, first thing first, I need to loop through all the primitive inside this polygon. Oops. And first thing I should do inside this loop is to get the poly number and check if this polygon is already filled or not. So if mprim group fill poly is equal to 0, then only if it's not filled yet, then you can use that primitive for filling. Okay, now next, actually, I just want to pick a random number of primitive out of this array. So what I want to do is to first shuffle this array, just in case I get a random random array or random order. So I think I need to use several functions connected to each other to shuffle the array. Let's see what I can use. I think I had reorder. Which can use the reorder stuff. Right. And this one has the arg sort. Okay. So if I have some random number arrays like this, I can use this arg sort to reshuffle the array. And is there any easy way to make a random array? I don't know. This only gives one value. I don't think anything will create arrays, so maybe I should still need to use for loop. Okay. In that case, first of all, I'm going to create an empty array which has all the unfilled polygon. Also, I'm going to have some random number array which is going to have some random values for each loop. Okay, which is then later used for arg sort. Okay, now that I have this randomness, let's create a order value using arg sort, using rands, then reorder the array which is in polys with order. And do I have to do like this? And probably this will enable you to shuffle the array for the neighboring primitives, just in case I want to make it randomish based on these seed. Okay, now that I have these randomly ordered values, I can also have another parameter. How many of those primitive that I want to use it for next run? Okay. Or maybe just one. I don't know. Let's see, let me think. It depends on how fast it's expanding. So, well, maybe I can just get one here. Just look for a single neighboring at this point. See if I can go back here later. So if the n polys length is more than 0, then get the first index, since it's already been shuffled, I can just get this first one, I think. Then set prim group fill, set prim group run, and for the current primitive you can set the run to 0, and let's also set the color to red. See what happens. Okay, so let's look this at from top view without shading. Okay, so it is expanding one by one randomly. So this is one way to go. I mean, you can wait, you can run this until the length becomes the total length, close to 3000, but as you can see, at some point it just stopped. Maybe it reached to the dead end. In those cases, it needs to look for from other places to expand, I guess. Okay, so you need more conditions here, for sure. Okay, so let's think about additional conditions. If it's been reached to the end, if it couldn't find any next filling spaces anymore, meaning you don't have any run group anymore. That's the conditions, I guess. Yeah, you do have a fill, but yeah, you do also have run, which is only 1 point, but if it's blocked by other filling geometry, then there's no way you can go next. That's when you need to do duck or add additional run groups from the existing fill group. So let's do that. Let's see how I can do that. I want to do it simple as possible, hopefully. So so after running this a little bit more, I think you are not going to have any run group. Yeah. Okay, so maybe I can search for this condition, and if there is no run group, then I can add additional run group to somewhere which is at the boundary of these red polygon, which is filled with which has fill group. Okay, so maybe I can remove this condition here. Let me check. Maybe before expanding, I can have another primitive group. And let's name this @run group. First of all, I want to search for total number of run group using expand prim group. This will give you a list of primitives which has a group called run. Now if the length of num runs, I should just call this runs. If this is equal to 0, then you obviously need to add more run. And based on the total number of fill, maybe I can add several number of runs at the same time. Okay, so let's also count up how many fill group you have. Okay, and how do I say this? If run number of runs is equal to 0, then first of all, what I would need to do is to decide how many additional runs that I'm going to add. So let's have this as a parameter. Maybe this could be a maximum number, and based on the total number of fields, which is in between 1 to, I don't know, 100, could be parameterized as well. And convert it into from 1 to maximum number of runs. I don't know if that makes sense, but let's see. In max field, currently the total number of areas is like 1963, so maybe 100, or maybe I can start with 100, which is like 5% of the whole primitive. Okay. Now, now that I have it, what I want to do is to add 5 runs to one of the runs here. I mean, yeah. So I don't want to get from first index to until fifth index using for loop, because that might just give you one next to each other. So I think it's a good idea to, I mean, my mistake, I need to look for the fields which is can be used for the candidate for the filling. So first thing I want to do is to shuffle this fill primitive. Okay, meaning gotta do the same things that I did for the other part. First of all, I'm gonna create a random array, but this could be inefficient because each time I want to shuffle, I need to make a random array, which doesn't look efficient at all. So maybe I don't want to do that. Yeah. Okay. Instead of doing that, I'm gonna just look. It's pretty hard. It's pretty hard. I do still want to shuffle it. Just don't know the efficient. Well, I'll just do the inefficient way and see if I can come back. Create an empty array for lengths of fields. Append random number to the rands with seed with iteration value. I can just copy what I have here. With seed iteration plus something else plus I. Okay, this will give you a value in between 0 to 1. Why do I have two rands here? Okay, so I'm appending these random value to the array. Now I can use this to create a order using arg sort and reorder the fields. Okay, now I can now loop from this first input, first index, which are already being shuffled. Okay, now I am going to count up how many fields that I have found. So I'm gonna create a integer value called count. Okay, time to do this. So get the fill. First thing I need to do is to check whether this field is on the border or not. So int polyneighbors and if one of the polyneighbors has a white value, meaning if it's not filled yet, then that could be on the border. So that's what I have to find out. Is there any other? Okay, so I think I need to again loop through all the fill and polys. And check if in prim group fill is equal to 0. And if it's equal to 0, then I can now use this fill number for a candidate. So how should I write it? Set prim group 0 run fill and poly 2 fit fill to 1, and you can now break. And you can also count up by 1. And you should continue doing this until the count is went to this run num. So whenever count goes above this value, then it should stop. So maybe this is where I should stop. If count goes up break. Let's see what it goes. How's it go? So I can check it by adding additional color node. What a primitive run make it blue. Okay, so one primitive has been converted into blue. Seems like it's working. Now currently it also gives the starting primitive as run as well. Did it? What about here? Okay, what about here? Okay, so it used two primitive to be converted into primitive to be run, which is okay. Okay, so let's check how's this gonna be. I'm going to update the color starting from white, use blue for the run, use red for the fill. See what happens. Okay. Looks like some kind of warm game. So you can see it's slowly growing over and over again. And after it's been hit to a dead end, it will regenerate the run group at some point, recreate keep expanding the route. Now this is pretty narrow road, so maybe I might need to add some conditions, maybe somewhere around something like here. I think it's a good idea to fill in those small spots, or like these, but that's like small additional conditions that I need to add later. But the main stuff here is running fine for now, I think. Expanding as it should be. Okay, so for now it looks good. Now next thing I should do is to stop this loop when the length of this border reach to the specified length, which is 3000 here. So I'm going to copy this value here and check if the border length is 3000. Okay. Now, how should I do that? Let's go to somewhere around 100 as an iterations. I'll see some problem here. I mean, I have some inner island like these, which needs to be filled in with the red, because these cannot be used as a route. I only want to use these boundaries as a route. Okay, so we need to fix that first. To fix this, I can first get only the fill part using delete. Okay, and first thing first, I only need a boundary. So use the by node, remove the inner edges. Now this will isolate the one that's inside the boundary. So what I could do is to just get the most biggest outline out of these. Maybe I can use measure node. Calculate the area, sort by area. Reverse and just get the first one. Okay, now I can go back to this one and refer to this boundary informations to fill in the color, fill in additional color. Fill the hole. So in this case, I think I can use a distance, or maybe a primitive number. No, distance. Search. If distance is small enough, then I can, let me make sure if this map is flat. Y has to be 0, but no, it's not 0. Okay, I needed to make a flat sum point. Okay, so I forgot to flat this original one. Okay, now it's okay. Okay, now if the distance is close to 0, then check if it's filled or not. If no, you can just say fill and set the color to red. Okay, now it fills the hole. Okay, and next thing I need to do is to check the border, the primitive lengths, the border lengths, which you can convert this to polypath and then calculate the lengths using measure node. For primitive perimeter and lengths. Okay, now let's see. And somehow you have two primitive here, which is problematic, I guess. You should only have one primitive. Okay, so you still have isolated stuff here, which wasn't available previously, so I guess I gotta do the similar things that I did here after using polypath. Remove the inner garbage. So what I can do for here, instead of using areas, I can calculate for perimeter. Sort with perimeter. Just get the first one. The biggest one available. Okay, now I can you only have one primitive and the length is already being calculated. You can also close this back to a primitive, a polygon, to use it with filling the hole. Okay, and let's also copy the perimeter from the second input. Let's not do this here, but I'm gonna copy to a detail wrangle. So primitive 1 perimeter, first one, gonna be apply to a detail attribute. Okay, so if it goes more than 3000, then that's when you want to stop the loop. Okay, it's already more than 3000, so I should have stopped it. So what I need to do is to create a conditions when to stop. Okay, so if perimeter is more than some value that I set as a parameter, that's when you want to stop. Let's create a value like stop. Okay, and the parameter that I need to use is this one, length of the route. Okay, copy this to the max distance, connect it here. Now I need to refer to this stop attribute on the detail to use it with this stop condition. I think in order to stop the loop, it's always a good idea to look for the first node value. So, how do I call this? Fail start. So I'm going to refer to the stop value on a detail on this node. If it's equal to 1, then that's when you want to stop. Okay. Detail. Stop. And it stop at 3063, and the length is 3245, and it's close to our threshold. And this is how it look like. Well, there are stuff that I don't like, such as these expansion, which doesn't really look nice at all. I mean, you don't want to walk like this, right? But at least it does meet with our condition. So for now, let's say it's okay, but I am going to fix it later. Okay, now after this, say I have got the things that I want. Next thing I'm gonna do is to just get these red areas using delete. Fill. And same thing that I did here. Remove. And just get the outline. So delete the inner edges and polypath. So basically this is pretty much it. You have now retrieved a length around 3000 meter by setting up the length and the starting point. Now after this you can do whatever you want, but next thing I like to do is to fix some of the map issues. Something like these really narrow route, which doesn't really make sense to go forward and go back to the same road. I mean, it's going the same road. The road has 3 lines, so that's what's happening here. So the next step for me is to fix this a little bit more to make it a bit more cleaner route as much as possible. So let's look for some conditions how I could fix it. So it's picking up so this kind of expansion is not so good. I mean, you could always change the seed. I mean, let's also create a random seed parameters here. From 0 to 10,000, 100,000. Copy this to expanding seed here, as well as this one. Nope, not here. Here is it? Here is it? Nope. Anything else? Anywhere else did I use the seed? Forgot. think I used it somewhere. Yeah, this one. Okay, so if you change the seed, you also change some route candidates. But some route has some problem, like these one. I don't really like it. I mean, it is correct based on the rule, but maybe I need to fix the rule to avoid something really narrow like these. Okay. So how can I fix that? Wait, how does it start? Start with these small shape. It's growing like these. So what could be the condition to have more nice expansion? One of the things that I could try is currently it's expanding one by one. The minimum expansion number for the run here is 1, which is being defined somewhere around here. Okay, out here. Oh, maybe here. So what I could do is hit min. If I type it to the same number here, I think it's gonna change something. Not much. Nope. My bad. I am... Seems like this thing is not really working well. So let me check if I'm doing correct. Okay, it's time to debug stuff. First thing first, this value. Let's say if I just use num as it is without fit function, does it change anything? No. I wanted to have more run group being made simultaneously, but doesn't seem to do that, does it? Nope. And let's move this to the end so that I know where the run group is right now. So it's already, it's always just one group. Okay. That is because this only runs when there's 0 count. So I need to fix this condition, I guess. If it's less than point number, then I mean the number of runs, then the additional number of runs is minus length. How's that? Okay, now it changed a little bit. So currently I'm going to have simultaneously 3 runs at the same time running to expand the loop, the route. And that makes the route much better, I guess, and much faster. Okay, that looks good. So this could be one of the parameter. If I set it to 5, I think it'll go much faster. Yeah, not bad. And it stopped at some point, and the length is close to 3000, and that's good. Okay, so this is good. Okay, one of the things that I want to fix is if I have a small area like these, which is being covered by these filled group, maybe I can just fill this with filling automatically with red one. even though it's not actually run, it's not actually expanded. Maybe I can just fill in those small gaps automatically. To do that, where should I do that? Maybe I can go back to where it created. So somewhere around here. Okay, somewhere around here. Somewhere around here I can try to fill this gap with some conditions. Okay, let's think about it. I'm gonna create additional primitive wrangle. Hello everybody. Thanks for joining. Fill the gap. Small gap. So I need to look for some conditions for these small areas. First of all, this is not fill. Okay, next it might have a connected to unfill, but just one. Everything else is filled. Okay, that's another conditions that I could give. So poly neighbors. Check for the neighbors. Check if that neighbor polygon it has fill group. Or unfilled group. And if it's just one, then maybe I can say it's time we fill that primitive. So what I need is the count value. Okay. Now if the count is equal to 1, now this is one of the conditions. And another condition that I want is if this is really narrow shape. And how would I get that kind of information? Well, I could try getting the bounding box informations, but that's not always work because sometimes it's diagonal shape. Area doesn't really work because could be narrow, could be just a small square. Maybe a length of edges might work. Okay, so maybe I can check the edge length where it connected with the unfilled polygon. And if the edge length right here is small enough with some threshold, then maybe I can fill it with red. Maybe that's some conditions that I can use. And if I want to do that, then I cannot use polyneighbors, I think. But instead I need to use half edge information. So let's start with getting the getting the hedge out of primitive number. So prim hedge, prim hedge, yeah. So this will give you one of the prim half edge number, which could be this one or could be somewhere else, like this one or this one and so on. And I want to check if that edge is small enough. Okay, so first thing I need to do is to look for the half edge, which is right here. So to do that, I think I need to do a while loop. First of all, gotta get the source. No. Gotta get the next equivalent hedge. Hedge equivalent. Next equivalent from the current edge number. A hedge belongs to a primitive, and the equivalent half edge means the primitive next to it, and half edge next to the primitive. So if we are looking at the half edge here, the next equivalent should be right here, and then we can also get the primitive number as well as if it is filled or not. So we can get the primitive number from this half edge. And if in prim group 0 fill prim, if it's equal to 0, then that's when you want to do the conditionals. Alright, I think I could still use this condition after all. Only if the polyneighbors is equal to 1, I can run this half edge. Okay, so I have to loop this half edge until it just rotate until it reaches to some of the half edge that I'm looking for. So that's next thing what I need to do. Okay, so while I need to have a starting half edge copied from the current one, and while start edge is equal to edge next is not equal to. Okay, so when it becomes equal, then that means you have just rotated 360 degrees. I mean, you have just go through all the edges, go through over all the edges. So that's when you can stop. Okay, and here you need to update the half edge. Maybe somewhere around here. Right, now inside these conditions, what I can say is get the length of this half edge. So the starting point of the half edge is source edge, source point at edge, edge destination point of the half edge, get the point position, calculate the distance, now give a condition. If the distance is smaller than some threshold of your choice, that's when you want to fill yourself with fill group. And when you have reached to this point, then you can just leave every loop. And that's when you end the whole process. Okay, now let's give some threshold value. This is a meter, so probably needs to be at least like 5 meter or 10 meter. Let's give 100 as a maximum. See if it's gonna change anything. Yeah, so it turned red when it's around 6. Okay, let's keep this 0 and look for other similar conditions and see if this still works. Okay. Gonna go till 100 and look, change the random seed. Okay, so this has several conditions. Like now this doesn't meet with our conditions, which is fine, but this one does. And maybe this one does as well. Yeah, so let's see if we could fix this one and this one right here by raising up the threshold value that I have here. Oop, it's changing since it's also changing the the ones previously, so it's not just changing the end, but it's changing the whole setup. Okay, in that case, I can just temporarily go to the last iterations and change it right here. Okay, now this one, no, I think this hole is gonna be filled with the setup, but what we want to care is these part. This actually, this is filled here, so it is gonna be okay. I might need to make this on the end, I guess, but no, I don't want to do that because this is already calculating the length, so maybe I think it's still okay to be here, but let's see if, yeah, so it is fixing the problem right here, just a small fix. Now let's set this to 10 and see if I can fix the other conditions. Okay, now I have a weird problem here. It's jumping. How could this happen? Totally wrong. So maybe I did something wrong with my conditions here, for sure. Okay, so okay, now I know it. Well, this condition is not enough, but I also have to check if the neighbor has at least one fill. Okay, so non-fill count. I also have to count fill count. If in prim group 0, else okay, so if non-fill count is equal to 1, as well as fill count is more than 0, that should be the condition. Okay, now, okay, well, this part should be fixed. Okay, this may be okay. This, if possible, I don't want to have these red one in the end. Okay, let's see where we have that. Okay, so I already have these conditions. It's not gonna be fixed by this one. It's because it's not it's not it doesn't have a unfilled group next to it. Yeah, that makes sense. Okay, what if I create add additional group additional conditions to here? Or non-fill count is equal to 0. This didn't really fix it, did it? In this case, I think this geometry doesn't have a neighbor which has an which is a unfill group, but this still doesn't work. Why is that? Because I also have this threshold here. No, this doesn't also work. That's because the condition that I have here rely on the primitive next to it, so it's obviously doesn't work. Right. But in this case, the other edge, I mean, this means that the other edge doesn't exist, that other half edge doesn't exist. So I can give some additional conditions inside here as well. Meaning this one, next edge, if edge is valid and edge is equal to 0, then you can just set this conditions plus this threshold distance. Else like this. Ooh. The distance, okay, still need to calculate the distance, which could be outside a loop, outside the conditions, I mean. Okay, still doesn't fix it. Wait a minute. If this is valid, that's not correct, is it? If this is invalid, or if hedge is equal to n hedge, let me check the vex function page. How does this valid function works? Just want to see, maybe I can have this one, hedge equivalent count. Maybe this should be it. Okay, so if hedge equivalent count for the edge is equal to 1, meaning you are at the border, you could still doesn't seem to work. That's it. Weird. Let me check if this condition meets. I'll just pick up this primitive, check the primitive attribute. The name was n fill something. So it says 1. Meaning it does have neighbor primitive which has unfill. Really? That wasn't I wasn't expecting that way. Why it became red. Oh. Not sure what's happening here. Why did it suddenly become red? It's already being filled in. That's not supposed to happen, is it? Just going to comment this out, comment these out, go back to where I was. Okay, so this this is the condition that I have here, and just want to fill here. And hopefully this works. No, does not work. Okay, and the reason is And seems like this primitive has, oh, wait a minute, this one is 0, so why it didn't work? So this will meet with this condition here. The other conditions is so I have an equivalent. First thing I am doing here is to check the equivalent count. If it's equal to 1, then that means it's on the border. Right? Else. Yeah. Yeah. And not sure why it does not work. Guess I gotta check one by one. I think I can comment these out and see if I have this condition at any point at all. Create an empty array. And add this value to here and check that value. Okay. Primitive array 2 2 2. Okay, meaning it didn't go till the didn't go loop, didn't go, I mean this has 4 edges, but it just stopped at some point. Is this the one that I'm preventing? 2 2 2, no. Okay. I think I'm misunderstanding the half edge, maybe somewhere. Maybe this condition is not correct. Maybe that's it. Okay. What if I move this half edge to here? Okay, now I have 2 2 1, but it still finishes with 1. And I'm not breaking anything. Huh. It's weird. That's not supposed to happen, is it? Nope. Okay. I think I need to change this conditions here. I'm just gonna say stop. And when the stop is equal to 1, then I'll stop the while loop. Okay. Now I can then check the next equivalent as well as calculate the distance and update the edge equal to next, and go to the next loop, right? And if the half edge is equal to start then I can break it. Maybe I don't need to say while, but I can say while 1. It's really dirty loop. Okay, well, this shouldn't work. Need to wait until you update the half edge. So it should be around here, I guess. Okay, now I have 4. Yeah, finally. Okay, that took a while. Now I can have the conditions that I wanted to check. And this works. Okay, finally. Okay. Let's go back to the end and check again. And try to see other geometry, changing the seed. And overall looks fine. I guess looks fine overall. Now let's also use this seed to change the whole noise map as well, so that I have more dynamical changes. Going back to where I was setting the noise map, somewhere around here, somewhere around here. Okay, and this seed could be replaced with the value that I have as a parameter. Okay. Now, changing the seed will dynamically change its shape. Oop. And hopefully the length is always close to 3000. Yep. Okay. Now I see some errors as well here. Let's check. Why is it jumping from here to here? That's weird. This is, when does this happen? Okay, let's also fill the color to check. At run group. This is on which? Wait a minute. What's this? Does this need to be primitive angle? Maybe not. This could be detail. Expanding. And for the detail, I can also set the color to the run RGB. Okay, so this became blue. That's fine. And this also looks fine to me. Does it? This one, okay, this again, this is a problem. Now for this one, there is no neighbors, so you need to have at least one neighbors for this one as well. Okay, getting close to the final. So many functions, so many conditions that I need to add. Okay, close. I still have those narrow stuff, but let's see. I think this should be filled, but maybe the length wasn't enough. Expanding made it till here, and made a fill polygon like this. It did closed it. So this is the one loop before, I guess. 22. So it could be 21. So this didn't fill the gap. Why? So to me it looks like it's being connected to only one neighbor, only on one unfilled primitive, but okay. So sometimes you had these long gap here, so it did fill the first one, but it didn't fill the second one. So maybe I can have this as recursively. Now getting more complex and complex. So I mean, this is all additional stuff, which is not really necessary if you're okay with the initial conditions, but I am not okay with it. Let's make a feedback loop. Okay, now it fills it. I guess 10 is fine, and I'm not gonna set the stop conditions for it. I mean, because it takes time. Okay, starting to look better, I guess. Yeah. Sometimes I have so small island like these, which is due to the noise map, I guess. This is the noise map, and if I offset it, somehow it becomes really sparse. I wonder if this is correct Where is the starting point? Starting point is right here. I mean, the initial map looks like this, and offset map looks like this, which doesn't look the same to me for some reasons. Why is that? Let me see. Maybe the calculation that I did here is not correct. It's not shifting in XZ direction, but it's also shifting in Y direction. Okay, I think I need to fix this. Okay, so. First of all, this calculation must be wrong. So let's forget about subtracting. Okay, so obviously this is more correct. So I guess I don't need it. But now that I need is to shift this. I mean, what if I subtract by offset? And I do have a starting point here. Okay, let me think back again. I do have an offset positions here, okay? Which is fine, which is supposed to be the point where the border point is equal to 0, right? Well, need to check that. Okay, I have named as 0. Let's copy. So this is where I added. Looks like it's on the border. If I clip it. Close to the border, I guess. Not sure if this is correct. Now, thing is, this is the starting point here. So what I want is to move the whole map from here to here. Okay. And I should be able to do that by minus offset plus spos. That's what I thought, but doesn't seem like it's working. Let's see. Nope, doesn't look correct. Okay, let me think back. I'm gonna reset this to at p for now. Okay. And from here, I have used the UV sample to look for the color black. And is this correct? Doesn't look correct to me. Okay, so maybe this part itself is wrong. Yeah, maybe the UV sample part itself was maybe wrong. I was looking for the black part, but it doesn't really seem like a black part. Let me also check the same UV sample, getting the color itself. Check that color. And the color is not equal to 0. Okay, so UV sample didn't work at all. Okay, I'll use, instead of UV sample, I'll try to use something else like PC find. See if it's gonna work. Okay, this was not expected. Okay, set. So instead of UV sample, not sure why it didn't work. Oh well. PC find 0. Looking for a point position. No. CD. With 0. Wait a minute. This will give you, what does this give you? Point number, is it? Yeah. A list of point numbers. That's good. PC find. The radius could be really big. Maximum number of point 1. So this will give you a closest point to the black color point. Okay, now get the first one and check that point position. See if I'm getting the right position on the border. It does looks like, so I mean, this is a starting point, is it? No. Okay, so this is a newly created point, and if I clip it, yeah, it's close to the border, so good enough. Now I can, what I would like to do is to, if the starting point position is right here, I want to move the whole map sliding from this point to this point, which should be easy because I have all the informations. So from this point to this point, I can calculate the vector of position minus spos. Let's call this of pos. So this is the additional vector for the map to be moved, and I should just be able to add this direction to this point position to move the whole map. Please. Yep, now it works. Finally. Okay, sorry for the hustle. Sorry for the wrong usage of UV sample. Okay, now it should be more reliable for the whole step. Okay, if I change the random seed, it's more reliable. All right. Now, I might want to edit more conditions, but for now I'll keep it as it is, and let's go to the final step, a visualization, which is pretty simple. I mean, you already have. Okay, I don't like these part. Let's fix this later. So I have these curve, and I have the original map information, like building. As well as road. You just add all of them together. And for the route that I created, I'm gonna use polywire to have some thickness to it. Set some color to this. What red? I'm gonna use object merge to look for building and road. Okay, merge these together. Fix the normal. And check. Where is the... Okay, I'm gonna turn up the lighting. Okay, let's thicken. Let's brighten up the red. There you go. Okay. Maybe there are a few things I could still... There are a few things that I still need to fix in terms of how the route is being made, but good startup. Okay, now let's go back to this is just a visualization, but the important part is the logic always. And okay, so this one doesn't have a candidate, so there's no way I can fix it at this point. So, or maybe I can go back to somewhere around here, yeah, to fix this one at this point using the same function that I have here. Maybe I can copy this with the same parameters. Yeah. Maybe I can just copy these. So all the parameters sharing with the original. And I can have another for loop. Feedback loop somewhere around here. I realize that in this case, it doesn't really, okay, should run from here to here. Now it doesn't fix the problem because right now I don't really have the fill group yet. It's just the color. So I guess I need to set the fill attribute at least temporarily. And why? I already have things like these. Candidate. Did I use anywhere? Use it anywhere? Yeah, right here. Okay. So instead of candidate, let's rename this to fill. So that we can share the same group name. And now it's being fixed here. This has to be fill. And I have to remake the fill from scratch from this point, so I'm going to remove all the group. Remove fill. Okay. This will reset the fill group. Now it's more clean. Now I don't... this one has to be fixed, I guess. Yeah. Okay. So what could be the conditions for this one? It's being covered by the everything with the filled one. Didn't I have that one? Doesn't this okay, so this only works if there are no if there are half edges. Okay. Okay. I guess I can falsely say that if this condition meets, then I can just say, just fill it. That means I didn't really need this while loop after all. Well, I mean, this conditions. I don't really need this conditions anymore. Now it fixes it. Yup. I guess this is better. Probably. Okay. Let's go back to see the final. Check with several seed numbers. Looking good. Much better than previously. Oh, I guess this is fine. I guess this can be set as one block. Yeah. So should be fine. Well, getting better. I think this is almost done. Yep. This is the funny route. Might be okay to have that kind of stuff at some point. Now I want to make sure, the final things that I want to make sure is that if the route is always touching the starting point, that is pretty important. So let me move the starting point randomly to make sure if this point always touches the route. Currently starting point is here, but the route is something like this shape, so it's a bit off. Let's look from the start. So at the starting primitive, so first thing first, it needs to be fit to one of the points on the map. So currently it's right here. So at this point it's okay if you increase it. Okay, so now it's the problem. When you expand in every directions, the point is within the boundary, which it loses its connection to the route. So in this case I need to reconnect this point, starting point, with the route somehow. So I guess that's the final things that I need to do in the end. So if I go loop till the end, get these shape, okay, so and the starting point is right here. So what I would like to do is to create additional like connecting line to the closest point on the route, then still make a circular route. So the maybe the starting road and the end road is using the same road, but maybe that's one thing you need to be overcome with. Okay, so to do that, let me go back to the road informations as well as this geometry information. So the road is this one, right? Okay. And you have this point is a starting point, which is this one. Okay, so let's gather all the informations that I need. First of all, a starting point. Second of all, the road information, which could be this one. Let's get that information as well. And finally, the outline, the final outline curve. Okay. Now, okay. First thing first. I am going to convert this into a bunch of lines for this basic road. Put some. Okay, now I'm going to find out the shortest path from the starting point to the closest point on the polyline. Okay, so need to find the closest point on the polyline. I'm going to connect this base road to the first input, which later going to be used with the find shortest path. Starting point connected to the second, the final route connected to the third. Now let's set some parameters for the find shortest path. First thing first, the starting point. New point. Okay, first of all, I need to get the starting point position from the second input. Then use that to look for a starting point number from the first input. Set point group start 1. Now next, I'm going to look for the target point, which I'm going to first use new point for the third input with the S-pass. And get that point position. And again, use this to look for the closest point on the first input. Then use point group to set the target group. Get the point position attribute. Okay, now use find shortest path from start to target, which will give you 1. How is this correct? How is this shortest? Oh, okay. Huh. So from this point, the closest point to the route is this point, but it has additional unnecessary curve right here, which could be deleted. Yep. So now what's next? So if this is a starting point, and if it's connected to this point here, then I need to split this polyline somewhere around here and go to this way or go to this way. Either way is fine, and then go back and come back to the starting point using the same road. So I need to make one circular route like that. Okay. Yeah. Let's do that. So to do that, I will need I will need at least to first of all delete these part, which is not necessary. So after having this, is this a polyline? Yeah. I'm going to convert this to a line, then remove the duplicated one to the original route. By checking the distance. Okay, now next I want to connect these lines as well as these primitive. So first thing first, I am going to convert this polyline to line as well. Let's make this white and check which point is connected to this curve that I have here. Okay, so, and there's supposed to be 2 points being connected. I mean, currently it's already being fused, so maybe I'm going to make these points unique at this point. So meaning 2 points could be touching with this curve. So let's find which point is touching. Okay, and should I use point wrangle? Maybe. Yeah, I could. Or maybe what I could do is use detail, and since I know where the start point, where the connected point is by checking the target group right here. And if I think the shortest path will create a polyline from start to target. Oh wait, the target is right here, so it doesn't walk that way. Okay, let me check how the point number is being created with these. So it's 0, 1, 2, 3, 4. Okay, so if I get the last point from this point arrays, that'll be the touching point that I need to be used. So I could get the point position from the point second input P. The last point number is n points -1, and then you can look for all the points which is close to this point position from the first input. Near points. With small amount of distance, and there's supposed to be 2 points, I guess. Okay, if the length of PTS is equal to 2, then you can just move the last point. Upward a little bit. Let's say moving 1 meter above. And okay, what's wrong with these? Declaration of, okay. And update the point position at PT with this one. Okay, now I have raised up one of the points on a primitive, and if I merge it with these one, I now have a connection like these, and I can also move this upward a little bit, like using the same amount of distance to the y direction. Now I can have a circular route. I mean, not exactly a circular, but at least it is. You can go back to the same position. Okay, let's parameterize this value. Calling this up. Okay, and finally fuse it, everything, and join it as one polypath, polyline, and going back to the visualization. There you go. Done. Okay. Now I think it becomes a little bit better overall. Let's move this up a little bit so that we can see it. Now let's try changing like distance, and also check the current distance value, see if it is close to what we asked for. So I'm gonna add a text or font node, looking for a parameter information right here. See how close it is to what we asked for. Detail. Final path. Final path. Perimeter. No, was called Peri. 0. Okay, I don't really need these fractions. Path 0, 4, or 5. Okay. Meters. Okay. Looks good. Now let's align with these geometries. Let's rotate this. Where is it? It's pretty small. Okay, let's rotate this minus 90 degrees and match the size with the buildings, or you know, match the size with the buildings. Okay, and let's place it. The Y is minimum. The Z is minimum. Nope. Maximum. To minimum. Nope. Maximum. Nope. Same. Okay, I want to move a little bit off to okay, doesn't change it. Justify minimum center. It's close. Okay, this is it. And give some offset. No, not this way. Yeah, like that. Okay. Maybe I should pad with 4 digits. Yeah, looks better. Okay. Well, the road, if the road is wide, it looks a bit too noisy, so give some dark colors. Yep. Looks good. Okay. And let's make this a little bit bigger. Alright, so let's test it out. Going back to the parameter. So if I change the seed, it's close to 3,000. I mean, it will always go above 3,000. Sometimes it goes pretty much. But at least you are getting pretty randomish route. Yeah, which is good. It's interesting. Okay, now what if I increase the route length like 8,000? Does it still work? Yep, it does. The calculation speed got a little bit higher, but I mean got slower, but you could always control that by triggering these values as well. Okay, max fill is not being used anymore, so just this number value, which is to determine how many run group you have simultaneously. So let's have that as a parameter, which could be pretty important. Let's say 20 max, but if it's too big, it might go easily off the goal length, so you might need to be careful. So if I increase this value, you have more rigid shape. And changing the route also works. If it goes to 1, the calculation got slower, I think. In that case, I need more loop, I guess. Let's make the maximum loop iterations to 1000. Alright. Yep. Looks good. Looks good. So now you can have unlimited. Okay, this is not good. What's this? I have a hole here, which needs to be ignored. Okay, so after doing this one, I need to do the same step as I have here. Okay. All right. Also, you can now change the starting point in 2 ways. One is to manually change the starting point. One is to use a radius and longitude, which I guess I will need a switch parameter. Okay. And copy this value, go here. Okay. If I check this, it will start from the latitude and longitude that I set. All right, let's also check where the start point is visualized. Okay, so I'm gonna use platonic shape. Tetrahedron is fine. I'm gonna color it with yellow. Then copy this to where the stop point is. Maybe I need to make this a little bit bigger. Okay. We need to raise this up a little bit above. First of all, it needs to be touching the ground. And I can give a little bit more size to it. And there you go. Now you can clearly see where the stop point is. And you can check that the route is always connected to the stop point. Yeah. Okay. Seems to work. And that's it. I think this is it. This is how I created a random route procedurally using Houdini and some noise functions. The logic itself is pretty easy. Just needed some conditions, small conditions to make it prettier. Okay, this is it. If you have any questions regarding to this, let me know. If not, I will end the stream, the live stream here. Okay, let me also check if there's any other parameters that I can change. What's this for? Okay. One thing I should make as a parameter is this one right here, which is a small parameter to fix the gap, but I think it's pretty important. So let's copy, where is it? This parameter. Okay, and also a noise related value could also be parameterized, which is which is here. The noise scale as well as noise threshold. Both gives you an option to control the size of the map, the noise map, or the shape, which could also drastically change how the route looks like. If the noise scale is smaller, then you should be able to get more roundish route. If it's bigger, you have more snake-like route, I think. More chance, I mean. And the noise threshold, if it's smaller, you'll have more, again, roundish route, more chance. If bigger, you have less island, meaning you might not getting any route as well. So it should be less than 0.5, I think. Let's make the maximum to somewhere 0.55 something. Yep. I'm gonna go as 0.45 for now. Okay, so this is it. This is how you can create a random route out of OpenStreetMap. If there are no questions, then I'll just end this live and lets you play with the file that I have just created. As always, I am going to upload the file to Patreon page, which you can freely access. You can download it and check it, play with it, and if you have any feedback, always welcome on the channel comment or video comment or Patreon page, whichever it is. And I'll upload it as soon as I finish this live stream. Okay. And if you are kind enough to support me on Patreon, that would also be great. Okay, that's it. Thank you very much for watching. If there's anyone still here, appreciate it. This is pretty wild. How does this route look like? This is pretty wild. I mean, you could always add additional conditions to deal with these narrow streets, narrow route. But anyway, I'm gonna stop with this. I'm gonna stop at this point. Hopefully you liked the live stream. Okay. And I'll see you sometime next week. Okay. That's it. Good night and good weekend to you. Have a good weekend. Okay.